This lesson is the inverse trig functions. The objective is students to be able to find missing angles in triangles by using the inverse trig functions. The big thing with this is that they are missing angles. You only use the inverse trig function, at least for this stuff. You only use it when you're missing the angle. If you're missing a side, you don't use the inverse at all. That's what we learned in the last lesson. So given the angles of the right triangle, find the missing side, round your answers to the nearest tenth. So this should be just a quick review over some of the other trig functions. So they give us this angle here is 34. So this side is your opposite. This side is your adjacent. Your hypotenuse is up here, but we don't use that at all. So OA would be TOA, so we use the tangent. So tangent of 34 is equal to the opposite over the adjacent. So it's equal to the opposite is 19 over the adjacent. Now remember, you could multiply both sides by x and then divide by the tangent of 34, but the shortcut I told you is you can just switch those places. So x is equal to 19 divided by the tangent of 34. So put that in your calculator, 19 divided by the tangent of 34. X is equal to 28.17. I'm rounding to 2 decimal places. Again, since it doesn't tell, oh, it says round to the nearest tenth, so sorry. I should round that up to 28.2. So you should always try to round with whatever they tell you to. If they don't tell you, that's when I always go to 2 decimal places. So this one, they give us this angle, so we have the opposite and the hypotenuse. So that's TOA. So that means we're using sine of that angle is equal to the opposite over the hypotenuse. And now to solve this one, since our x is in the numerator, we multiply both sides by the denominator. So that cancels. 18 times the sine of 63 is equal to x. So just type that in your calculator. 18 times the sine of 63. Again, make sure your calculator is in degree mode for this. And that ends up being 16.0. And this last one, this is the angle we know, so we have the adjacent and the hypotenuse, so that's TOA, so that's the cosine of 65 is equal to the adjacent over the hypotenuse. So again, for this one, we're going to multiply both sides by 18. So if you type that in your calculator, 18 times the cosine of 65, that gives you 7.6. So that's just a quick review of what we did in the other lesson, and that's where, again, we're missing one of the sides, but we knew all the angles. If you look at this, the first angle is 34, the second angle we knew was 63, the third angle was 65. We know all the angles. We're going to get to where we know the sides, but we don't know the angle. So given 2 sides of the right triangle, find the missing angle, you need to use inverse or inverses. You need to use the inverse. Again, you only use the inverse when you're finding an angle. That's what a lot of students struggle with, and it's a lot easier if you realize you only do it when you're finding the angle. So in your calculators, the inverse function is represented by sine to the negative first. To get to those in most of your calculators, you hit your second button and then hit that. So for sine on my calculator, there's the button that says sine. And then if you hit the second button first, right above it, it says sine to the negative first. So you hit the second button and then hit sine. But for these, we're literally just putting this in our calculator. So if we have the sine of theta is equal to 0.4384, then the inverse sine of that gives us our angle. So the inverse sine of 0.4384 is 26.00, so 26 degrees. So again, really what we're trying to do is, what angle are we going to get where the cosine of that angle is this decimal? So what angle would be in here that if we took the cosine of that, it would be this? Well, to find that, we're going to take the inverse cosine of this, the opposite of the cosine. So the inverse cosine of 0.5592 is 55.999, which rounds up to 56. And same thing with the tangent. The inverse tangent of 2.9042 is, again, you get 70.99999, which is 71. you want to put 0.0, you can. So that's just showing you how to put it in your calculator. And I kind of explained a little bit cosine of what we're doing here. But this is going to help you a little bit more with why we're doing this and what we're doing this. So before, just a quick example, when we had 2x is equal to 10, we wanted to cancel that 2 to get the variable, this x, and so we divided by 2. But the reason we divided is because that's the inverse of multiplication, so they cancel each other out. That's the opposite of multiplication, so it cancels it out. That's what the inverse is. Well, now it's the same thing here. This is the variable we have, but to get this tangent to go over here, you need to take the opposite of tangent, which is the inverse tangent. So you do that to both sides, inverse tangent. So the tangent of what angle would give us 1.7321? Well, put that in your calculator. So theta is equal to the inverse tangent of 1.7321. So inverse tangent 1.7321. So that angle is 60.000. Since we're only going to 4 decimal places, that's why all the other ones were almost 71, but not quite, almost 56, but not quite, a little over 26, so on and so forth, because they're rounding to 4. If they would go to more decimals, it'd be different. So same thing over here with cosine. Well, I want to know what that theta is, but to get that variable, that theta all by itself, we need to cancel out cosine. So I need to take the inverse cosine of both sides. So theta is equal to the inverse cosine of 0.2079, and so we put that in our calculator. That gave us theta is 78.000. And actually it says round your angle to the nearest degree, so I could just say that's 78, and I said that was 60, so perfect. Same thing with sine. Don't make this harder than it actually is. Sine to the negative first. Sine to the negative first. Technically, this should be written in front, but I'm just writing it down so you kind of can see that example or see what I'm doing. Sine to the negative first of 0.4076. So second sine, 0.4076 is 24.05. Again, we're rounding to the nearest degree. Now, last one, we have 12 over 13. There's a couple ways you could do this. If you want to make it into a decimal right away, you can, but instead, that's just 12 divided by 13. And so I'm just going to put it in my calculator. I'm going to take the inverse sine of both sides. And so my A is going to be the inverse sine of, and I'm just going to type in 12 divided by 13. So the inverse sine, and then I just put 12 divided by 13. Hit enter. That gives you A is 67 degrees, 67.38, and again, we're rounding to the nearest degree, or the first whole number. Same thing for all these, inverse tangent, inverse tangent. So B is equal to the inverse tangent, tangent of 3 over 4. Again, I just typed on my calculator how I see it. The inverse tangent, 3 divided by 4 is 36.86, so that ends up being 37. It's the nearest degree. And inverse cosine, so x is equal to the inverse cosine of 8 over 25. Now, I know some of you guys are going to ask, do we really need to write this whole thing out that I'm putting in red right here? And my answer is, I'm not going to make you do that, but I would strongly recommend doing that, especially while you're learning. I either need to see this step or I need to see something like I did up here, so I can kind of see that you know the idea of that. But again, I think it helps a lot if you just take it nice and slow and show all those steps for the first several times you do these. That x ends up being 71 degrees. And I should say, I'm not going to make you label, but just so you know, those are all degrees. We're finding the angle measurement. We're finding those degrees. So find the missing angle with the triangles below around your answer to the nearest degree. So now it's the same thing we did before, except for now we don't know the degree. So this is the degree we're looking for. So we have the opposite and the hypotenuse. So if you look at SOHCAHTOA, that's so we're using sine. of that question mark is equal to the opposite over the hypotenuse is equal to 46 over 53. Now, if you want to reduce that, you can, but before you do that, I would just put in my calculator where I'm going to now take the inverse sine of both sides. So my question mark is the inverse sine of 46 over 53. And then just type that in your calculator. Inverse sine 46 divided by 53 ends up giving you that angle is 60.2 degrees. So that angle is 60 degrees. Now, if you don't like the question mark, if you want to make an X or a theta, that's not a bad idea, but I'm going to stick with that since that's the way they give it to you. So again, this is the angle they're giving us. So they have the hypotenuse and they have the adjacent. That looks like so TOA. So it's the cosine of that angle. Question mark doesn't look good. Is equal to the adjacent over the hypotenuse. And again, all you're doing now is you're taking the inverse cosine. Now again, I just want to make sure you realize the only reason we're taking the inverse cosine is because the angle is what we don't know. If we knew that angle was 50 and we didn't know this angle or this side was 15, then it'd be different. But if it's the angle that we're trying to find, that's when you're going to use the inverse. That's the only time. So my question mark is the inverse cosine of 15 over 43. So inverse cosine 15 divided by 43. Question mark is 69.58, so that rounds up to 70. We're rounding to the nearest degree. This one, the angle we're missing is this one, so the opposite and the adjacent, so that means TOA. So we have the tangent of my question mark is equal to the opposite over the adjacent. Again, to cancel out tangent is the inverse tangent. So we have my question mark is equal to the inverse tangent of 5 over 12. So second tangent, 5 divided by 12 is 23.61. So that ends up being, 22.61. That ends up being 23 degrees. So I would encourage you to do these on your own and then put play so you can check your answers, but it's going to help if you try some of these on your own without my guidance. So hit pause. Once you're done, hit play to check your work. So for this one, we have the hypotenuse and the adjacent. That means we're going to use TOA. So we're using cosine is equal to the adjacent over the hypotenuse. Again, if you want to reduce that down, you can, but I wouldn't waste my time because I'm going to put it in my calculator anyway. So that cancels. My question mark is inverse cosine of 4 over 6. Inverse cosine 4 divided by 6 is 48 degrees, 48.1. This one we have the so I'm just making sure that's right. This is the adjacent, again, the adjacent and the hypotenuse. So again, this is TOA. So the cosine of question mark is equal to the adjacent is 18 over the hypotenuse of 42. So the inverse cosine, 8, Make sure, again, when I write it up here, it's just kind of to jot some notes down, but make sure the inverse cosine comes before that ratio. If you do it the other way around, it's not quite right. Especially to type it in your calculator, that's the biggest thing you'll mess up. That ends up being 64.6, rounds up to 65. I should have done a better job with this because it looks like all of them are cosine. Oh. Sorry, this is 14 again. Already did that one. That's funny. So 15, we have the adjacent and the opposite. So that's a little bit different. So that's the tangent is what we're using. Of question mark is equal to the opposite over the adjacent. It's 17 over 19. Inverse tangent, the angle is the inverse tangent of 17 over 19. So inverse tangent of 17 over 19 is 41.82, which is 42 degrees. Again, you don't have to put the degree mark, that's fine. Now, the rest of these are story problems, and I will say they're not all inverse story problems. Sometimes you need the angle, sometimes you don't need the angle. You're just going to have to make sure you read carefully, and I would definitely make sure I draw pictures with this. It's going to be a lot easier if you draw pictures. So there's a light that is broken outside your house. It's 10 foot above the ground. So we have my house right here. My light is up here, and that's 10 foot above the ground. You use your 13-foot ladder to fix it. So a 13-foot ladder means that's how long it is. So if I put my ladder up there, that's 13 foot. You lean the ladder against the wall, so the top of the ladder is right at the light. That's what I drew up there. What angle does the ladder make with the ground? Now you have to be careful and make sure you're reading this correctly, because this is the angle that would be with the ground. Up here is the angle it would make with the house. So you have to make sure you're knowing what angle you're talking about. So what does that angle make? So this is the angle. Again, if you want to call it X, you can. A lot of times people call it theta since it's an angle. Up to you. So we have the opposite in the hypotenuse. So that means we're using sine of that theta is the opposite of the hypotenuse is 10 over 13. And again, from here, we're doing the inverse sine of these. So that cancels. My theta is equal to the inverse sine of 10 over 13. Inverse sine of 10 divided by 13 is 50.28. It doesn't tell you what to round to. Again, my general rule of thumb is to go to 2 decimal places if it doesn't tell you to. But I'm not going to be too finicky or too nitpicky about that. How about this one? A boy is flying a kite that lets out 300 foot of string. So we have this boy, he's flying a kite that's way up here. And the string is 300 foot. Assuming the string is straight, so that makes life easier. How far, oh, sorry, I skipped over. And it makes 38-degree angle with the ground. So the ground is right here. That's 38 degrees. Assuming the string is straight, how high above the ground is the kite? So definitely make sure you read the whole question. So we know the angle now. We know this angle is 38, so we don't use the inverse. We only use the inverse if the angle is what we're looking for. So from here, we know the angle, and we are dealing with the opposite in the hypotenuse, so we're going to use sine again. I know the sine is 38, and then the opposite is x. The hypotenuse is 300. And now, again, we don't need to use the inverse of sine because we already know the angle. So from here, to solve for that side, we just multiply both sides by 300. Type that in your calculator. 300 times the sine of 38 is 184.698. Again, it all depends on what you round it to. If I round to 2 decimal places, since it doesn't tell me, that'd be 70. That's not a 6, that's a 0. Again, if I were you, I would pause the video and do these on your own, and then hit play to see your work or to check your work. Sorry, it's supposed to say ladder. A ladder leans against the building. The top of the ladder reaches a point on the building which is 18 foot above the ground. So here's the building. We have the ladder here. That point is 18 foot above the ground. The foot of the ladder is 7 feet from the building. Find the angle and measure the ladder makes with the level ground. So again, we're looking for this angle now, for the opposite and the adjacent. That means we're using tangent of this angle is equal to the opposite over the adjacent. And again, now we're using the inverse of tangent. So theta is equal to the inverse tangent of 18 over 7. That angle ends up being 68.749, so I'm going to put 7.5. And the last one, a wire attached to the top of a pole reaches to a stake in the ground 20 feet away. So we have a pole right here. Here's the ground. A wire goes from the top of that pole to the ground 20 feet from the foot of the pole. So that's 20 feet here. Makes an angle of 58 degrees with the ground. Again, make sure you're careful with that. Find the length of the wire. So again, we know the angle. They tell us that angle, so now we don't need to use the inverse. We have the adjacent and hypotenuse, so we're going to use cosine. 58 is the adjacent over the hypotenuse. Again, now that we have this set up, the x, since it's in the denominator, we switch these places. X is equal to 20 over the cosine of 58. 20 divided by the cosine of 58 is 37.74. So, not a lot harder than the last lesson, but make sure you're being careful. Again, make sure you're only using inverses when you're finding the missing angle. If the angle is what is missing, if that's what you're looking for, that's when you use the inverse. If you have any questions, please let me know.